So this is how you would want to set this particular problem up. All right, and then I'm just going to fill in what I know. I know the rate. They actually tell me the rate. How fast was the mayor of Clarkston driving? 50. How fast was the mayor of Blair driving? 55. How long did they drive? 3 hours. This is, rather simple, right? You don't have variables, do you? Other than the final one. So how do I find the distance for the guy from Clarkston? I just multiply these, right? How far did he drive? I'm assuming that was 150, right? How far did the guy from Blair drive? 165. If I want to know how far apart they were, what do I need to do with those? You need to add those up to get the overall, and you're going to get 315 miles. We have a freight train traveling to the fuel station and back. It took 1 hour less time to get there than it did to get back. The average speed on the trip there was 60. Average speed on the way back was 50. How many hours did the trip there take? So we are going to draw our little chart. We're going to say that we have a trip there and back. And so that's going to be our 2 that we have here is there and back. And then we have, of course, our rate, our time, and our distance. Okay. And so for this one, I'm going to say, well, they drove there and they drove back. All right. And then I need to know my rate, my time, and my distance. All right. So on the way there, do we know how fast they drove on the way there? Yeah, 60 miles an hour. How about on the way back? Do we know how fast they drove? 50. Time. Do we know anything about time? 1 hour less to get there than to get back, right? So you could do this 2 ways. You could say 1 hour less. Well, that's time minus 1, right? So the first guy took less time. Or you could say the second guy took an hour more. T plus 1. It actually doesn't matter which way you do it. You're going to get the same answer. So if you said this guy drove a certain amount of time and it was 1 hour less than the other on the way back, then I would have to add an hour to the way back, right? Because it should take 1 more hour on the way back. Actually think about this too if you don't remember which way to do it. If he's going 60 miles an hour and this on the way back is going 50, logically, shouldn't the 50 take more time, right? Does that make sense? So it should be time plus more hours if he's going slower, okay? And so think about your logic there when you're not sure where to put that. The longer time should go with the slower speed, okay? To find my distance, I literally just multiply across like I did for bell work. So I'm going to say 60 times t, and I'm going to write it just like this. And I'm going to say 50 times t plus 1, and I'm going to write it just like this. Now, if I walk to Lewis and then walk back, that distance should be the same. There and back is the same distance, okay? And so I'm going to say, well, the 60t should equal the 50t plus 1 because he went there and came back. The distance he traveled is the same. And so I'm going to actually set it up that way. 60t equals 50t plus 1. And then I solve for t, right? Now, solving for t should be something that you know how to do. This is Algebra 1, right? We're going to distribute, move our variables to one side, our numbers to the other. And so when I do that piece of it, distribute this guy, we have 60t equals 50t plus 50. Subtract my 50 over, so I have 10t equals 50, t equals 5, all right? Make sure you're solving for the right thing. Had they said, how long did it take to come back, you would not be done with this problem, right? Okay, you would have to add an hour. But they asked how long it took on the way there, so I would say, well, it took 5 hours. And you could say, is this logical? Is 60 miles an hour at 5 hours the same as 50 miles an hour at 6 hours? Yes, it is, okay? And so I know that at least those things match up. I at least have a logical answer here. For number 2, he traveled towards the recycling plant. May left 1 hour later and traveled in the same direction, but with an average speed of 60. Find the number of hours Adam traveled before May caught up. All right? So in this case, they're both leaving at the same point and they're both ending at the same point, but one left later. Okay? And so we're going to do the same thing here. We're going to draw our chart. And we are going to fill it in with what we know. Solve for what we don't know. All right, so we have this. We have two people, Adam and May. They love to give me crazy names here. All right. All right, and we're just going to fill in what we know, rate, time, and distance. So do we know the rate of either one of them? Yeah, we actually know the rate of both of them. How fast was Adam going? 45. How fast was May going? 60. All right. We know that May left 1 hour later. This is the same thing as the there and back, pretty much. Who should be taking longer to get there, Adam or May? Adam, right? Yeah. And we know the difference in the time is 1 hour. So you can do it either way. You can either subtract an hour from the faster person or add an hour to the slower person. But we know the difference is going to be 1 hour, right? And so if you don't want to deal with negatives, you could say, well, the slower person is going to take 1 hour longer. So I'll just put the t here and the t plus 1 in the slower person. Or you could have said Adam is t and the faster person is minus 1. Either way. But the slower person is going to take longer. The faster person is going to take less time. Okay? And then to find my distance, I multiply across. 45, parentheses, t plus 1, 60 times t. These distances are the same. They left at the same point. They ended at the same point. Their distances are the same, so we're going to set them equal to each other. 45, t plus 1 equals 60 times t. At this point, you're just solving algebraically. Distribute. All right. We're going to subtract our 45t over. I should probably write that 15t. All right, so t equals 3. Am I done? Who did I solve for? Adam or May? What are they asking? Find the number of hours Adam traveled. I am not done with this problem. I solved for t, but that is this person right here. They want this person right here. What do I need to do to that t? I need to add 1, and that's where we get our 4 hours here. A jet left New York and flew towards Dublin at an average speed of 188 kilometers per hour. An Air Force plane left 6 hours later and flew in the same direction, but with an average speed of 470 kilometers per hour. How long did the jet fly before the Air Force plane caught up? This is actually identical to the one we just did. They left at the same point. They ended at the same point, okay? And so you are going to set it up exactly the same. You're just going to have different things that you know and do not know. So you're going to do your chart. Every time you're going to want to do probably a chart to get an idea of what's going on. You have two different things here. You have a jet and you have the Air Force, okay? We're going to fill in their rate, their time, and their distance, all right? Rate. They give us the rate. They hand it to us. How fast was the jet going? 188. What about the Air Force? He was zipping along, right? One of them left 6 hours later. So the difference between how long they travel is 6 hours. Which one of these is going to take longer? The jet is most definitely going to take longer. And we know the difference in their time. It is 6 hours. So you can either say that the jet took 6 hours longer, or you could say the Air Force is T minus 6, right? One of them needs to be, when they give you a difference in something, one of them will be that variable and one will be the difference in it, okay? So they gave us a difference in time of 6 hours. One of them needs to be T for time and the other needs to be either plus or minus the hours. The slower person is going to be plus, the faster person would be minus. So whichever way you set it up, you're going to get the same answer. One of them needs to just be the variable. The other one needs to be plus or minus the variable, depending on whether you put it for the fast one or the slow one, okay? And then you've really got your problem. You just multiply across. You do 188 times t plus 6 and 470 times t, right? We know these distances are the same. They left and they caught up. Caught up is always the same. So I'm going to say 188 t plus 6 equals 470t. I am going to distribute, what is it, 648, so 480, 1080. What is it, 1128? What is 1128? Okay. All right. I am going to solve here. So just subtract my 188t over. All right. So when I divide both sides, I should get 4, right? So t should equal 4. What did I solve for, the Air Force or the jet, if I solved for t? The Air Force, right? What is it asking for, though? The jet. So I'm not done. The jet took 6 hours longer than the Air Force. So I need to take that 4 and I need to add the 6 hours longer. And that's how I'm going to get that 10. It says a cattle train left Seoul traveling west 1 hour before a passenger train. The passenger train traveled in the opposite direction, going 5 kilometers slower than the cattle train for 9 hours, after which time the trains were 1,000 kilometers apart. Find the cattle train's speed. So for this one, they started at the same point and they went opposite directions, and then they told you how far apart they were. So that means this distance and the other guy's distance should be added together to get the total distance apart. Okay? So if you and your friend walked opposite directions, how far each of you walked should be added together to see how far apart you are. And that's all we're doing here. We are going to set up the same exact thing, though. We are going to set up a chart. So we're going to set up a chart here. We are going to see what we know and what we don't know. All right? Always the same as far as the chart goes. All right, we have a cattle train. All right, and then we have a passenger train. Cattle train and passenger train. So they give us a lot here. 1 hour before. So who's going to take longer? Who's been traveling longer? Well, the cattle train, 1 hour before, okay? Then it says the passenger train traveled for how long? 9 hours. So if we know that the passenger train traveled for 9 hours, and we know the cattle train left 1 hour earlier, how long did the cattle train travel? 10, right? So this is not one that we're going to set a variable. They actually told us both of these. The passenger train traveled 9 hours. And earlier they said the cattle train had been traveling for an hour already. All right? And so he traveled an hour longer. We know how long the passenger train traveled. So we just add 1. This is not a time where you would put a variable. We know both of those actual numbers. All right? The passenger train traveled in the opposite direction, going 5 miles an hour slower. So do we know how fast the cattle train was going? We don't. We're going to put an R there. Okay? Was the passenger train going slower or faster? The passenger train was going slower, right? The passenger train traveled in the opposite direction 5 miles slower. So if the cattle train was going R, how fast was the passenger train going? R minus 5. So if I'm driving 55 miles an hour, right, and Malia is driving 5 miles an hour slower than me, you would just subtract 5 from 55, right? So just because we don't know it doesn't mean we don't do the same process. They're going R minus 5, okay? And then we have the same setup. We're going to multiply across. So we have R times 10. That's going to be 10R. 9 times R minus 5. Now the difference here between this one and the ones that we've been doing is these are opposite directions. They do not equal each other, okay? They're going different times and different speeds. They're not going to be traveling the same distance. We do know, however, how far apart they are, and the two distances should equal that. So we're going to say 10r plus 9r minus 5 equals the total distance apart, which was how far apart? 1,000. And once again, we have a pretty simple problem to solve here, right? We're going to distribute that 9. We're going to combine our like terms over here. We're going to add the 45 over. And then you would divide by 19. So R here equals 55. I want to double check and make sure I solve for the right one. All right. The R represented the cattle. Find the cattle train's speed. I'm done. If they had asked for the passenger, what would I have done to that 55? Subtract 5. So he's going 55 kilometers per hour. And that would be my answer. So once again, we're going to apply the same techniques to these types of problems that we've been doing to the distance, rate, and time problems. You're going to read the problem, note your key words, your key phrases. What type of problem do you have? Plan it. This may mean a table. This may mean a geometric drawing. Write an equation and then solve the equation. Once you've done that, make sure you answered the question. Did I answer what they asked for, or did I just solve my equation? You may have set up the equation to solve where you have to go back and do something else afterwards. And is this reasonable? Does it make sense? Whatever I came up with. All right? So, the last type of problem we're going to do in this section are called mixture problems. Mixture problems. These actually also get set up with a chart. So you're going to look through here and you're going to say, what two things do I have? What am I mixing together? What am I trying to solve for? And then you're going to set up a chart based on that. A fruit punch is made by mixing together an orange drink that costs 89 cents a liter and a lemon lime drink costing $1.19 a liter. How many liters of each must be mixed to produce 30 liters of fruit punch valued at $2.18 for a 2-liter bottle? All right. So, in this case, you're typically going to have 3 when you draw a chart. So we've been doing 2 rows, and you're actually going to have 3 because you're going to have your 2 pieces of it and your final mixture. Okay. So you're still going to draw a chart, but you're going to draw it a little bit differently than you would the other one, because you have 2 things that you're mixing together to come up with a final mixture. And so you want to have a line for each of the individual pieces as well as the mixture itself. And then you want to come up with, well, how much, the quantity that I have, right? The next column is either going to be a price or a percentage, right? And then the last column depends on what you're looking for. So let's look at what we have here. We have a fruit punch. It is made by mixing. So my final mixture is that fruit punch, right? When I mix these 2 together, my final product is going to be a fruit punch. That guy is what's going to go down here. All right. What am I mixing together? Well, I'm mixing together an orange drink and a lemon lime. All right. So you have the 2 first lines are going to be what you're mixing together to get your final product as your last line. Okay. In this case, we are doing liters. Okay. So we have, a final product, we want how many liters of? 30, right? So I'm looking for how many liters. I know how many liters I'm going to have finally. I'm going to have 30. That's what they told me. I want 30 liters. Do I know how much orange drink I'm going to have? No. So I'm just going to put a variable there. I don't know. But if I know the total is 30, then the orange plus the lemon lime should equal 30. So how would I back into how much lemon lime I have? Well, I could subtract out how much orange I have, right? 30 minus how much orange I have should equal how much lemon lime I have. And that's what you're going to do. You're going to say, well, 30 minus however much orange I have. Because we don't want multiple variables. We just want one. All right? So if I have X liters of orange drink plus Y liters of lemon lime, I should get 30. Well, in order to avoid having that Y, I'm just going to subtract it out. Right? So if I say orange plus lemon lime equals 30, then to find one or the other, I just subtract. Well, I already said that this is X. I can subtract the X over, and that's what I'm going to put there. Make sense? Everybody see why I did that? That's how these are going to be if they give you a total amount, by the way. All right, the next thing we're going to talk about is price. Price per liter specifically. All right, price per liter. How much is the orange drink per liter? It is 89 cents. How much is the lemon lime?
$1.19.
How much do they want people to pay for 2 liters of the mixture?
$2.18.
Okay, now here's the problem. The other ones are per 1 liter, right? Does everybody see that? So it needs to be in the same unit. So if I have 218 for 2 liters, how much would it be for 1 liter?
109.
Yeah. Does that make sense? So pay attention to how they've worded that problem. Because if you put $2.18 there, you are miscalculating it. You're doing it with 2 different units. The first 2 are in 1 liters, then the last one would be in 2 liters. Okay? Now, overall price. So total cost here. If I want to know how much the orange drink's going to cost me, I have to multiply the liters times how much it is per liter. So I'm just going to multiply straight across. 0.89 times however many liters I have is how much my orange drink is going to cost. My lemon lime drink, well, that's going to be $1.19 times however much lemon lime drink I have, right? And then my fruit punch is going to be 30 liters at $1.09 per liter, right? Does everybody see that? So then I should be able to add down how much my orange drink cost plus how much my lemon lime cost should equal my total cost, right? And so that last column sets up your equation. I'm going to take this last column and I'm going to make my equation from this last column. I'm going to say, well, 0.89, that's my orange drink, plus the $1.19 per the 30 minus X should equal 30 times $1.09. Okay? Does everybody see that? Now, personally, I would get rid of my decimals, but if you're using a calculator, it probably doesn't matter. I would bump all those over and make that 89, 119, and 109. That's just me, because I don't like decimals, but you don't have to. At this point, we're just solving. We're going to distribute. Okay. Do I have enough zeros? 0? One more 0? No, I'm right. Right here. Yes? Because they don't have a decimal. Okay. That's just 327, yes. Combine my like terms. What are my like terms over here on the left-hand side?
89 cents.
Yeah, my 89 and my 118. I'm actually going to get a negative number, but that's okay because I'm going to end up with a negative over here. So I do this minus that. This guy's going to be negative. Is it 0.3? Is that right, Lois? Check me. Equals 327. All right, subtract my 357 over. They were nice right here, weren't they? All right, so we have negative 0.30x equals negative 30. What is my x going to equal? Right? 10. What did I solve for? X equals 10. Look at my chart. Where's X? Orange drink. Specifically, how many liters of orange drink, right? They want how many liters of each. So for the orange drink, I need 10 liters, right? How much lemon lime if I want 30 liters overall? 20.
20, yeah.
It is the same as your distance, rate, and time. You're just getting different variables thrown at you, okay? So let's walk through this. They give me a total overall, right, of a mixture. This is my bottom. They tell me the two pieces that I mixed together. Those are these two pieces right here. These two pieces should add up to my total, okay? Then they're giving me sum per, a price per item, a percentage per item, whatever it is. And then they tell me what they want the overall to be. All right, these are the three pieces. How much each one is, how much the overall is. This column is going to be multiplying across, just like your distance, rate, and time. How many liters times how much it cost is my total cost. How many liters times how much it cost is my total cost. How many liters times how much it cost is my total cost. And then these two pieces should add up to the total. This piece plus this piece equals that piece. Okay? Don't let the fact that they had crazy decimals throw you, right? You have a calculator. I'm not going to make you do it in your head. All right? So this piece plus this piece equals that piece. So I just wrote it like that. 0.89 plus the 1.19 times the group equals this. And then you're just doing algebra. Distribute, combine your like terms, solve. Then make sure you know what you solved for. I solved for X, but what was X in my chart? By the time you get to the bottom of this, you may not remember what X was in your chart, okay? So you need to go back and say, what was X? Oh, X was how much orange drink I had. Did I answer the question? Well, partially. They wanted both. So I need to figure out the other guy. Well, I just subtracted it from 30 because I know all of it equals 30, and I had 10, okay? That's what you're going to do with these. What do I have? What do I need? Do it a piece at a time. Here's what I don't want you to do.